Okay, so this is the same project that I'm going to send to y'all. I'm just gonna run this down from top to bottom. Okay, so this is all stuff you download with, so don't worry about it. Okay, so I don't know if y'all have worked with semaphores before, but this is just declaring a semaphore. These are all the functions that I've written up to this point. We have a function for enabling peripherals. This is to look at the UART with the tera term. This one is for one of the timers. I was following the YouTube video and they initialized timer 1. We don't really use it for our lab, but it's in there, I guess, if you want to work with it. So you have the interrupt as well. You have the timer that goes on forever, which is timer 0. We're using pin E2, so I set up the interrupt for that and what it's going to do in the interrupt handler. And then line detect is our function. That's our task for reading the values and stuff. So these are the two variables we're using: start time, end time. Enable peripherals, straightforward. It tells you what it does. Local, the UART, this just sets up the UART thing. You don't have to worry about this. Timer 1, like I said, you don't really have to worry about it because we're not going to work with it. So yeah, I'm going to skip these two. If y'all want me to talk about them, y'all can let me know. Timer 0, so we're using the wide timer. I wanted to do 64 bits, but it goes way too long. And also an int value doesn't go up all the way. So it's just funky having to work with that. So we're still using the wide timer, but it's 32 bits now. So configure it to be periodic up, only use half of it, so 32 bits. Set the value with the largest possible, and then enable it straightforward. And there's no interrupt with this one, so this one's just good to go. Pin to interrupt handler, or the interrupt initializer. So the E2, the peripheral is already set in the peripherals function. And then you set what kind of interrupt it's going to be. So a falling edge interrupt, enable the interrupt. And then I called this again. It was being funky and I was kind of commenting in and commenting out stuff to see what would work. And this was what ended up working. GPIO, the int handler. So it's going to clear the interrupts. It's going to, I don't know why it's doing that twice. So let me get rid of that. Yeah, you don't want that twice. It goes at the end. It's going to read the time, which is your timer 0 base. I divided by 50. There's no real specifics. The frequency of the clock is 50 megahertz. So this just puts it into megahertz. You can work with the math and stuff if you want to make the numbers come out nicer when you're calculating stuff. So, but it gets the value, puts it in end time, and then semaphore post. This means you can go and call the semaphore again, which goes into line detection where it gets blocked right here. So this task doesn't continue until it gets unblocked, which is done by the interrupt handler for port E. The line detection turns it into an output, sets it equal to high, wait for 10 milliseconds. I did the math here, what that looks like. Start the timer, or get the value for start time, and then set it to an input, and then it's gonna wait for that to go from a 1 to a 0, where it goes back into this function, the interrupt handler, and then it can start running again. In the main, you set the clock at 50 megahertz, enable the interrupts, the peripherals, the UART, the pin, the interrupt handlers, timers, all that stuff. Print that it's running, and then BIOS starts. I don't think you need to do anything else with the RTOS. And like I said, if you need anything, you can just watch the YouTube video. I would recommend watching the video at least the first 15 minutes. It'll go over the basic RTOS stuff that y'all need. But yeah, that's pretty much it for now.